The system includes optical resource, gas controller, and reactor. Three parts. When you start to use, first, most important is the optical resource. This one we have tested the optical distribution and it's a solar simulator. And the wavelength is start from 380 to 780. If you want to use a filter, you can refer to our training and for install a filter here to got the single wavelength optical resource. Install the optical filter by screw it in. The one recently installed is for wavelength 420. Then you can test the distribution. 420 cut means from 420 to 780. Normally, optical resource provided is 380 to 780. Below 400, some researcher make it to be see it belong to UV. So sometimes they will ask you to cut the UV. At that moment, you can use this 420, cut the one below 420 to leave the one from 420 to 780 is pure visible. So this is a range cutting, not the sub cutting. So you can use this one. Then use this one, you can adjust the angle to face to your optical window. Then use this one to control the optical head. When everything ready, you turn the light to let it go. Then you can locate it to your reactor. Keep the fiber freely to let it follow its texture. Don't make a dead angle to the fiber. If you would like to shift this to left and right, you can remove the nut at the top, a little bit release the black hand, and you can shift it to front or pull it to back. This one is for optical part. This flow meter you can replace if the flow range is not suitable for your filter study. Recently, the flow rate control is from 1.6 to 16 milliliter per minute. Then the gas flow from this side in, then going this side out to going into your reactor. We can see from the reactor there is a gas distributor to plug in the gas in, and your working electrode fits to the optical resource, and your reference electrode installed beside the working electrode, and the looking capillary tip fits to your working electrode. And another one you can install with a Teflon tube for liquid collection, as in our training. And the port you don't need, you can block it by the blocker. In the middle, you will install the membrane, and in another chamber, you install the counting electrode. You can see we also installed a gas distributor. You can decide if your reaction is require a good gas distribution near the electrode. You can replace this gas distributor to the working electrode side. And the counting electrode is a platinum electrode. You can use it, putting it here. And this is a single wave valve. Pay attention to the direction of the single wave valve. Make sure the gas flow in from here and out from here. You can collect your gas sample from this side, as in our training. And this is the demo for how to collect a liquid sample. Then you can use same thing and suck your liquid from the top of the tube and keep in the liquid storage. After you finish the reaction, you can slide down the cap to forbid the more leakage of optical to outside to protect the operator. This one can slide in and slide out, slide in and slide out. When you plan to take out your reactor, you detach all the connection with other accessories, like if your electrode was connected with your potential state, remove it. And if your gas inlet and the gas outlet was installed with some other device, you remove it to detach the all accessories first, then only take the reactor out. When you install the electrode, you make sure every nuts on the bottom of the nuts there will be a O-ring there to hold the device to forbid the leakage. For more details, you can refer to our previous video for how to install the reactor. Slip down. Okay, hold it properly. Use the reactor to slip down. Hold. If you not hold everything, it may go leaky. Hold, then lock. Use the screw here to lock it. And before you lock down, you pay attention to the flat here and make sure it's flat. If it's not flat, you can release here a little bit, adjust it. So when it's very tight, you cannot adjust the angle anymore. It may crack. So this one you adjust before you tie. Then you can slightly adjust the memory waist thing. Then after you finish, you can tie it. Now you can fill in water to see whether you seal properly. If you are not seal properly, and maybe at the beginning when you are not have good experience, you got the memory slide here and there, and just to practice several times. If you got your own experience, like how to angle, you lay down, or you put it, or you search another people to hold for you, then you down yourself, whatever. And if you practice, got your own experience, the final target is not leaky. So this is all done for the reaction. I think. Cut the memory, you have two ways. One is you put the memory on the top, hold the memory and knock it. But I don't like that way. That way, sometimes it slides. So I like it to put a paper board on the table. Then I use my cutter, focus on the position, use my weight to push it. Then the extra tray, of course, in your case, you need to sit to decrease the application. Then you will got your slide. This one later you can use for here. Then you use this original, put here, write a round circle. You can use scissors to cut the middle one. Then you will got a new O-ring for yourself. For example, this is the membrane we already got. Then how to hold it? Because your memory cannot seal automatically, so you have to put one O-ring on the top. Put one O-ring on the top. Put your memory on the O-ring. Then another O-ring on the top. So the sequence is reactor, O-ring, membrane, O-ring, reactor.